Let's have a look at the very next question. Smoke particles are introduced into a glass box containing air. Light shines into the box so that when observed through a microscope, smoke particles can be seen as bright points of light. Describe the motion of the smoke particles and account for this motion in terms of the air molecules. We understand that the smoke particles or the motion of the smoke particles when observed through a microscope will be a random, unpredictable motion which consists of random, unaccountable collisions either amongst the molecules themselves or between the molecules and the walls of the container. And these collisions are not limited only between the smoke particles. The collisions also happen with the air molecules. From this, we can conclude that as a result of these collisions, the air molecules will start to move faster because there is an exchange of energy, and the air molecules also become or also appear smaller and lighter, and they also undergo random motion exactly like the smoke particles. Moving on to the next part, figure 5.1 shows quantity of gas in a cylinder sealed by a piston that is free to move. The temperature is increased. Now, as you increase temperature, we are asked what happens to the piston. Now, as you increase the temperature of the gas, the molecules of the gas gain a greater amount of kinetic energy, or the kinetic energy of the gas molecules increases. As a result of the increase in the kinetic energy of the gas molecules undergo greater number of collisions, or the energy exchange is greater, and as a result of this, the piston moves to the right. As a consequence of this piston moving to the right, the volume will increase. Now, as a result of an increase in temperature, volume V also will increase, but in the due course of this, pressure P will remain a constant. Moving on, the piston is now fixed in place and the temperature of the gas is increased further. Explain in terms of the behavior of the molecules what happens to the pressure of the gas. Now, moving on, here we are asked that the temperature is increased further while the piston is kept in a fixed place. And this means that volume V is kept a constant. And since volume is kept a constant while temperature is increased, pressure will also increase, because pressure P is directly proportional to temperature T. This is because as a result of or as a consequence of increase in temperature, the average kinetic energy of the molecules will increase, which will result in greater number of collisions while the surface area available remains the same as a consequence of the piston being fixed. And since the number of collisions or the force exerted by the molecules between themselves and with the wall of the container is more, the pressure P also will increase.